Hello friends, welcome to my channel. Let's have a look at problem 2246, longest path with different adjacent characters. In this video, we are going to share a solution based on recursion. First, we'll read through the problem statement to digest the requirement. And then we do the analysis and make some analogy. And finally, we explain and share the code. First, the problem statement. So we are given a tree rooted at node 0 consisting of n nodes numbered from 0 to n-1. And the tree is represented by a zero-index array parent of size n, where parent I is the parent of node I. So node 0 is the root, so we set that parent 0 to be -1. So this is just a treatment. So we are also given a string s of length n, where si is the character assigned to node I. So we can understand this si as the label or name of the node I. So we are required to return the length of the longest path in the tree such that no pair of adjacent nodes on the path have the same character assigned to them. So here are two examples. So first, let's look at example 2. So for sure, the output for this problem is 3. So one of the valid paths can be 3, 0, 2. So here we want to mention that in this problem, the graph or the tree is not necessarily binary, right? As demonstrated by example 2. So another thing we want to emphasize is that the path is not necessarily to be a pure downward path. For example, here, so the path is 302 or 201 or 301, right? It's not a pure downward path. So this is about example 2. So for example 1, so the output is also 3. So and here 0, 1, 3 is a valid path. So here there are 3 nodes on the path. So we define the length to be 3 here in this problem. So with that said, let's also look at the constraints. So first, the parent list and the string s have the same length n, and this n is bounded in between 1 and 10 to the power 5, and 10 to the power 5 is a decent large number, right? So the parents represent a valid tree, and s consists of only lowercase English letters. So with that said, we are ready to do analysis for this problem. As we mentioned that this problem is a graph problem or a tree-based problem. So when we treat problems related to graph or trees, so we can first think of recursion to see if recursion can help solve the problem. So in this video, so we're going to use recursion. So this problem it's actually quite similar to Leetcode problem 543, the diameter of a binary tree. So essentially, they are the similar problem. So one difference here is that we are in a general graph context. So here we show for each vertex v, we examine the length of the downward valid path passing through or starting from this vertex v. So here valid means that the adjacent nodes or vertices have different labels, right? So in general, the longest length of the valid path or a valid path passing through V is the sum of the length of the two most longest downward valid paths passing through the vertex -1, right? -1 because we count this V twice. So this can be seen readily from example 2, right? So from the root 0, there are this special node. There are 3 downward paths, and their lengths are 2, 2, 2, right? We pick 2 longest, that is 2 plus 2, then minus v itself, that is 3. So the return is 3. So in this problem, and for our task, we could do DFS, and in between we could update the longest length, right? So for the update, so we can use non-local variable or we can use attribute, right? So with that said, we are ready to write the code. First, we are going to use a attribute here, attribute. So we are going to initialize this. Let's result to be let's initialize at 0, right? So then the second step is to build the graph or the tree, right? So here the graph is a tree, right? So first I'm going to get the length of the parents list or the number of nodes. I'm going to first use a adjacency list default dictionary. So we're going to use set as container, and then so we're going to iterate. So notice that the node 0 is the root, so we're going to iterate from 1, right, up to n-1, right? In other words, we write n here, right? So then what we're going to do is that graph the parent of v. So we are going to add v to its parents, the neighbor. So here, let me mention, so this graph is directed. So in general, the graph, the tree, so it's not a not necessarily to be a directed graph, but here we use directed graph. It's very convenient, just for convenience. So next, so we're going to write the DFS hyperfunction, right? So we're going to write like this using recursion. So DFS. So we're going to accept a node, and then we're going to return another integer. So that is the length of the longest downward valid path, right? From passing starting from v. So let me make some annotation. Return the length. So let me write length of longest a longest, right? A longest valid downward path, passing or starting from v, right? So for this, in between, we're also going to update this attribute. So for this, I'm going to do this first, second. So the longest and second longest. So we're going to set it to be 1 and 1 at first. So what we're going to do is to examine the neighbors for neighbor in graph v, right? And then we're going to get the length of the longest downward path passing through the neighbor or starting from this neighbor, right? So first we need to make sure the path is valid. So we're going to do this if SV does not equals to S the neighbor. So this this means that the adjacent nodes have different names or labels. If this is the case, so we're going to update the first and second. So if the longest downward path passing through neighbor so is greater than first, right? So if this is the case, so we're going to do this first, second to be the adjacent list, and then the first. Otherwise, so let's see, the adjacent list is longer than the second, right? So in this case, so we're going to set first it remains unchanged in this else block, and then we're going to set the second to be adjacent length. So this first and second will represent the length, the longest length passing through its neighbor, one of the neighbors, or from let's see this variable. And then what we are going to do is that we find the length of the longest valid path passing through this v. So the path length will be so the first plus second, then minus 1, right? So then we're going to update the attribute to be max self result, and then the current length, right? Then we're going to return 1 plus the first, right? So 1 is counting the v, right? The node v, and the first is the longest one. So this will be the main logic. So next, so we're going to do the return or the problem logic. So for this, we just need to call this DFS, right? Call it from the root. And then actually this function returns something. We can just write DFS0, or we can use some dummy thing. And then we're going to return self result. So let me first make some test. Yeah, it passes one example. So now let's look at the generic case. Yeah, it passes all the generic cases. First, let me comment here, right? So if we have a graph which is just a single node, right? So this will be, we will not enter this block. But here, the path update is still right, because first plus second minus 1 will be 1 plus 1 minus 1 is still 1. But here, update is also right, but the return, so 1 plus first will be 2. Though it's not representing a valid a genuine path, but it, the problem logic, so the logic here still works, because here we are mainly using this DFS as a worker to update this attribute result, right? So this is the one point. And another point is that, so when we do the update, so here we are using the attribute, so we can also use a global variable. For example, let's see, I commented out this, and then we're going to use a result to be 0. And then, so when we write this function, let me first non-local this result, and then we're going to do this. Let me comment this out. Let me write it like this: result equals max result and pass this. This will also do the job. So, but here we need to return the result. Let's do a check. Yeah, this is another comment. Third comment is like this. So here we are using a dictionary representation, dictionary and set representation of the graph. But here you can also do this: graph equals let me use a list for in range n, right? Because we have n nodes. So then what we're going to do, we can use same thing here. But when we do the check, so here it's not add but append. So this also do the job. Let me first comment this and then do a check. Let's do this. For sure, you can also associated with this format, you replace this by attribute. So let me recover the original code, right? Let me delete this one and recover back this one, and then let me recover back this part, and then delete this part. And then here we're going to do self result, and then we're going to return self result. So here let's comment this part to make the code clean, and then let's test again. Result right here. So let me comment out this or delete it. The generic case. Yeah, with that said, I guess that's about it for this problem. So in a follow-up video, we're going to look at this problem again, revisit Leetcode problem 543. So essentially, this problem 543 can be solved using exactly the similar idea as here, or we can see in the reverse direction. So with that said, I guess that's about it for this problem and this video. Thank you.